Hi, I am Anusha Chatterjee. So this is my final project of the subject MFG. In next 4 minutes, I will walk you through AI-based traffic congestion prediction and visualization pipeline. Think of it as 4 layers stacked end-to-end. Number 1, synthetic data generation with TimeGAN, 2, pre-processing and LSTM forecasting, 3, route optimization with NetworkX, and 4, interactive dashboards in Bokeh. So here you can see the Jupyter notebook. So the notebook begins by fixing seeds and hyperparameters, so every run is repeatable and finishes in about 3 minutes on a CPU. Because real sensors feeds are hard to share, we bootstrap our own. So here create minimal real data fabricates 300 really sequences of 24 hourly samples, each sample holding speed and volume. Those real snippets drive TimeGAN. Inside train TimeGAN, you will see 4 subnetworks, that is embedder, recovery, generator, supervisor, trained jointly for epochs, that is 150. After training, TimeGAN generate and TimeGAN recover spit out 400 new 24-hour sequences. That's roughly 10,000 synthetic observations that statistically mimic the real ones. So a quick prints confirm the shape 424.2 and shows a preview of the data frame, timestamps plus normalized speed and volume. So here key talking point is instead of waiting months for sensor to fill a database, we manufacture a rich privacy-free dataset in minutes. Next, preprocessed traffic data flattens those three-dimensional arrays into a tidy pandas data frame, minimum maximum scales the two signals and adds an hour of day categorical feature. For forecasting, we keep things intentionally lean. The core model is a single layered GRU with 64 units followed by dense layer of 32 ReLU neurons and final one node output layer. We fed 24 step windows, train for 10 epochs and print the performance. On our synthetic set, the root mean squared error lands at about 0.04, meaning the model already predicts the next hour speed within 4% of its scale range. Now, LSTM are not helpful unless they guide drivers. So we embedded them in a tiny road graph. The function build road network sketches 5 nodes labeled A through E. Edge weights equal a static latency plus the latest predicted volume times a random congestion factor. So heavier traffic literally makes an edge more expensive. Once we call the function nx shortest path prints an optimal route list. In today's run, the console shows A to C to D to E. Finally, we visualize everything. Plot times reads renders the last 500 points of speed and volume. Hovering shows exact values and timestamps. Plot network draws the spring layout road graph. Thicker, darker edges highlight congestion and node tooltips reveal IDs. Here you can see the proper outputs. To recap, we generate realistic traffic profiles, predict short-term speeds, optimize routes on the fly, and visualize the whole story interactively. Next steps include fusing real CCTV feeds, swapping the GRU for an attention model, and deploying the notebook as a Bokeh server for citywide dashboards. So that's all about my project. Thank you for listening.